Welcome to Dakota Area Transfer. So this is our side that we take all of our construction debris, demo. If we have anything over here, it's going to be Class A fire. This is probably not the side you guys would be responding to. You'll probably be responding over there. That is all the MSW. That's where you're going to have your lithium batteries and everything. We've got loads come in, and usually they're in roll-off boxes on this side. They'll come in, they'll dump. Once they come across the scale operator will tell them which door to go to. They'll come in here, dump. The scale operator is talking constantly to the operators so that they know where there's a truck coming, where everybody's moving at. And then we're pushing, we're separating wood, steel, aluminum, copper, everything out that we can. And then once we have a pile here and we get semis coming in, we'll load over that wall over there. That is, take us about 21 minutes to load a semi, and then they'll go out. Anything over here is gonna go to a construction debris landfill. Same thing over there, except for everything over there is gonna come in a garbage truck, whether it's a rear load, front load, side load, and then anything over there. We'll sort out what we can, but there's a lot of that is just gonna go into a truck. And then this is gonna go either to Iowa or to Wisconsin to a landfill.
Some of you guys were here on the response, that one, okay? So you guys came into these, looks like it's a big concrete vault. Trucks come in this way, we load them over the wall, and then they drive to Iowa, or Wisconsin, okay? We did put in a system that you guys saw when you guys were here, where we have eyes that'll see the fire. We have cords that'll also, another layer of protection, that'll see heat and then set the system off. And I'm gonna let Eric Yoda talk all about that here shortly. You know, the big thing about this area, this building, is when we set up that night, we were on the wrong end, right? You guys, who made entry? Did you guys make entry inside, right? Right, so there's a lot of learnings we took from that response. You know, I took some learnings during that response that evening was, you know what, I gotta get the loaders out here, the loader operator out here right away. So when I'm getting called moving forward, I'm gonna call for an operator, because you guys we're gonna need it, depending, especially the fires more than likely are gonna be on that side. And what do you think we're fighting? What do you think's the ignition source? Lithium batteries, right? It's been a challenge, and our team's been learning a lot where, you know, we talk about, you know, we have eyes, and Eric's gonna talk more about them. They sense it, right? It calls you guys right away, right? So you're coming. And then after that, if it senses, if it's 2 out of 2 where the other eye catches it, it's gonna dump the system, right? And we're talking about a lot of GPM, and Eric's gonna talk more about that. So I'm gonna turn it over to Eric, but real quick, do you have any questions for us staff here?
Is that just a weekday operation, just daytime?
It's 5 a.m. to 5:30 p.m. Monday through Friday, and I think it's 5:30 to 2. Yep. 5:30 to 2 on Saturdays, which is, we have some routes that come in here, some MSW, but we really keep it open for the public, you know, for them, because we have a public drop-off right out here by the scale house.
So the sprinkler system is you know, designed kind of like a normal sprinkler system, but it's a pre-action. So the piping's filled with air, and there's no water in the piping because it would get cold in here in the winter. And it's not like a dry system where once it loses air pressure, it trips. It requires releasing panel to trigger it. And so the way that we're detecting for that is we've got some flame detector cameras. And so if you kind of look up and see the red camera up there with the green light on it, that's one of them. And then we've got another one in the corner there for this side. And then we've got the same thing on that side. And so those flame detector cameras are kind of tuned to pick up like a 1 foot by 1 foot flame that flares up. So it's got to see it flare twice before it'll trigger. And they're cross zones. So the first one is going to call you guys. It dispatches you right away, just like any other normal fire alarm. And that's so that you guys can get on the way. If it's during the day, some of the time they've been able to, you know, take care of it that way, drag it out with a loader and take care of it. Because lithium batteries, have everything they need in them to burn. They don't need oxygen. They would burn underwater. It's a thermal runaway event. And so there's really not much you can do other than cool it and let it burn out. And the little cells tend to burn out. And so one of them triggers and calls you guys and gets you on the way. If the other flame detector catches it, or say if it was on that side, both of those, or that one and maybe this one, then it would trip the system and it'll fill it with water, even if a sprinkler head isn't activated yet. And that's so that it's ready to go once we get enough heat to activate it. And then we've got some areas that we can't cover well with the flame detector cameras. So if you kind of see on that pipe, there's like a white wire running underneath it. And that's a linear heat cable. And then we've also got that over here where the garage doors are at. So it runs out over the garage doors to cover the area that the camera there can't see. And so the linear heat cable is, they call it CTI, so you can short it out and break it and it won't trigger. It can actually measure the temperature, so it knows if it's gotten hot there. And so that will release the system and fill it with water also. And that would dispatch you too. So.
What temperature?
190 degrees. So the sprinkler heads are 200 degree and the linear heat is below that. So you should trigger it before you trigger a sprinkler head. So, and here's kind of a layout of what we're looking at, oriented the way we are. So that northwest flame detector is the one that's right there. And so that's the way they're labeled, come up on the panel and then should get dispatched to you that way. Yeah, so they're pretty robust. You're supposed to be able to weld in front of them and not set them off. We don't want to try it, but it's the flame. But it's got to see the flicker too. So like if you take a IR radiant heater that puts out the same spectrum as a fire and set it in front of one, it won't go off. Now if I take that and wave my hand in front of that, it's going to go off because it saw the flickering. So it's looking for both the the signature, the IR signature, the frequencies of light from the fire, and it's looking for the flickering and changing.
I mean, it caught us doing fire training where the trucks are parked. We went over there and we're doing fire training with a pan. We had Dan Corrigan out there working it, and we set the system off. So yeah, they are it works.
Yeah, and for that reason, we've got it set so both of the, both of the north ones can't trip the system, because the way this building sits up raised, when it covers out to the garage doors, it also sees out into the field quite a ways out there. And we could have a time where there's a fire out there that it's going to pick up if they burn that field. Yep, garage doors are open. They're gonna get busted pretty quick. And then the reason we've got linear heat here too is because if you're down in the bays down there, the flame camera won't necessarily see it. So on the night of the fire, the first flame detector over there, the southeast one, caught it, but we never got the northeast flame detector because they were piling the garbage and had kind of a slope off the back. It wasn't tight against the wall, and the fire was down in that. So it wasn't up high enough that it could see it. And then we've adjusted the detector sensitivities since then. So it was a real learning event on all sides.
Yeah, we've also adjusted how we're piling the garbage against the wall.
But that heat tape will tell, or the heat cable will tell you where it breaks.
Yeah.
So it'll give you a length. Like that night was 974 feet. It broke.
And if you look, so 0 is back at the riser room, and 200 is kind of at the corner there. So that drive bay, if it's telling you your break and your temperature is somewhere between 0 and 200, it's in that drive bay area. If it's 200 to 870, it's out in this garage door area somewhere. And then 870 to 1080 is that drive bay, and 1080 to 1644, I think it is, would be over that way. So we'll show you later, we'll activate it, and then it'll show you that it's shorted in the distance, and it'll also tell you the temperature that it's at now and the temperature that it got to, so the maximum temperature it saw. So it's smart enough to know whether it's an actual heat event or not. And then let's walk over here a minute. We've got some hose reels and a hose station here. So both floors have a hose reel on it, and it's dry right now. There's no air in it, or there's no water in it, it's air. And there is a manual valve you'd have to open, or we've got a 2.5-inch hose connection down here with a valve there. That will only work if the system's activated and has water into it. So we're designed so that you guys can pull 500 gallons a minute for your use. We can have 250 gallons a minute from here and 250 from the wall hydrant back at the riser room and still operate as designed.
And that hose, we're at like 150?
Yep, about this nozzle is just under 100, I think it's 120 gallons a minute out of that nozzle. And it's an adjustable nozzle. I'm sure you've seen them. So it's set down to like 60 gallons a minute to start with, just to make it a little easier to handle off the get-go. It does not reach all the way back into the corner there. It's about 10 feet short, but then your hose stream should make it, so. Right here is where the water tank's at, and here's the second access into the tank. So there's about 141,000 gallons, and it extends from here to about 8 feet inside the building there. And it's 9 feet of water. It's a little deeper than that, but the waterproofing gives us a water level of about 9 feet. So there's a lot of water, and then the bollards are here because it's just a precast concrete deck so that nobody drives on it. So right here we have the wall hydrant or the fire pump test header. And so this is where you'd be able to get water out. There is a valve inside you have to open also. So if you're looking to get water out of here, and we'll flow water a little later, you have to open up the valve inside, and then the pressure on the system will drop, the fire pump will kick in, and then when you come out here, you can open up the valve to get water, and then you can hook up to an additional 1 or 2, whatever you need to. So, and then the signs here and inside, it says 500 GPM max during sprinkler system operation. So that's what it's designed for. So the FDC right here with the 120 volt horn and strobe above it, the fire pump in there is 1500 GPM at 150 PSI. And so NFPA 13E says if you hook up, you'd be at about 150 PSI to start. And that's about in the range of the system there. So, and then another thing, if you come in, as soon as we set one flame detector off, it sets off the horns and strobes inside the building. But this one doesn't activate until we have water in the system. So if you drive by here and see that that's not active, there's a pretty good chance we don't have water in the system. So if we look, here is the water tank. And then if you look over a little bit, you'll kind of see the white stripe down there underwater. Mm-hmm. That's where there's like a 4x8 hole through the foundation wall to connect us to the rest of the tank out there. And then the pump sits down in a recess. So there's a, kind of a recess down there so that you can use all the water out of the tank. It'll pump all the way down to there. So other important things in the room here. The fire panel is hidden behind the fire pump controller back here. On the panel, don't hesitate to hit buttons. Look at the screen. The red light here for alarm tells us that the system is in alarm. Supervisory tells us that we have things like a low air alarm or a valve closed or open outside its normal position. And the red release light tells us that the system has activated and filled with water. We've released the system. And then we can hit acknowledge here, and it'll tell us which alarm we're on. And then we can also hit the down arrow and scroll through the different supervisories that are up there to see what is there. If you get multiple alarms, a lot of times you have to hit the arrow to see everything else that's there. And then next to it here, we have the display for the linear heat cable. And that's where you can kind of tell the distance if that's activated. And then as far as the system here, we have a vertical turbine fire pump that pulls out of the tank below ground and then pumps the water through the header. Here's the valve that leads out to the wall hydrant outside. So if we open this up, we'll get water out there. And then we have the first zone here is a wet zone. And so that just covers this room. This is the only heated room. And then we've got the foam water pre-action zone here. So this is the one that covers the rest of the facility. So one way to tell if the system is tripped and filled with water, down here we have a gauge that tells us water pressure on the system, which is just over 200 psi. And then if we look up here, we've got air gauges. So that's the air pressure that's on the system. If the system activates, those will match. So you'll have 150 to 200 psi on both sets of gauges. So that's one way to tell. If for some reason there isn't water in the piping and you need it out there, something didn't work, electronics failed, we didn't activate, there's a little red box here. And this is the emergency release, or better known as the oh shit handle. So the valve is different than normal. Most valves are parallel to the pipe when they're open. This one is backwards. So you grab that, pull it down, it bypasses all the electronics and trips the valve and fills it with water. And then we've got a foam tank here. So the system, the code only requires water. Initially, we had foam water running to it all the time, but it's really expensive to refill. So that night burned through most of the foam, and it was like $30,000 to refill. So they've changed how it works. There's a green valve handle right there, and they've got the nice ladder for us. If foam is needed, if you decide to use foam, that's where you would turn it on. You open that one valve, and that'll let foam into the system. You can let it do what it needs, and then you can shut it off again. And foam is really, lithium batteries will burn underwater, so foam doesn't necessarily help there. Foam does work well for solvent fires or flammable liquids, like if there's paint or gasoline, mineral spirits, something in there. If you get a pool of fire burning across the floor, is a good time to use foam. And then foam is supposed to also make it slippery and help it penetrate the garbage pile if needed. So 2 times that it would be good to use. Yeah, so the jockey pump, the way the system typically works is the jockey pump maintains pressure, and that only gives us about somewhere between 10 and 20 gallons a minute. And so that's designed to keep the system filled, keep up with leaks, but not overcome a sprinkler head. So once that can't keep up, then the fire pump senses the pressure loss and kicks in and runs from there. So, any questions so far on the once over? So if you guys were looking to get water out of it, we got to open 2 valves. So if someone wants to open that valve, and when you do that, it's going to sense the pressure loss, the jockey pump you'll hear kick in, and then the fire pump will kick in after to keep up. And so once you got it open all the way, we'll walk around outside. Yep, it is on. If you look at the display here, you can kind of see what it's doing also. So right here tells us it's green, we have utility power. This is for the backup generator. It's red, we don't have power there. We can see it's about 480 some volts, and it's pulling about 150 amps for each leg. And then we're maintaining pressure there. So we'll go outside and open up that hose and flow some water. You would see the pressure drop. Well, and if you're flowing water in there, the pressure is going to be down quite a bit. Okay. So if someone wants to open up the hose valve there, and then we'll get water out. Yeah, that's all you got to do to get water. Yeah, or you can close it. Yeah, that's all you got to do to pull water. We can head inside again, and if someone wants to close the valve, oh, thank you. So who wants to close the valve? No? It's pretty easy. So now once that's closed, we don't have a lot of water flowing. If we look here, you can see that it's maintaining pressure, right about 200 psi. Now that we're not using it, it's maintaining pressure. I can press and hold the red stop button for just a minute. It'll drop a little bit, but not a whole lot. And once it's stopped, if I let go, since it's maintaining pressure, it shouldn't start again. So since we're not flowing water anymore, and then we've also got the jockey pump here, and so this will kick in. It tells you on there about 165 psi. The fire pump is also on a generator, so if they lose power, it'll fire the generator up to run. If for some reason, like you're here and the system's activated and you decide you've done everything you need to and it's time to shut it off, if we still have the system active and heads open, it's still going to be flowing water. If you're going to shut the pump off in that scenario, you would press and hold the red button, and then we'd have to shut off the disconnects. When you shut off disconnects on a fire pump controller, we've got a sign, but you got to shut off the generator power breaker first, and then the normal power breaker. Otherwise, if you shut it off the normal first, it'll sense the power loss and it'll kick the generator on and start back up. So if you hold the button and shut both off, then the pump is off.
Talk about the refill.
Yeah. So right here, we have a level controller that measures the tank level. It's normally between 8.5 and 9 feet. If we look back in the corner there is an automatic solenoid valve, and then there's a manual ball valve down below it. So we can go in here and tell it to go into level simulation, and then we can just dial the level down here. When it gets to 8.5 feet, it opens up our automatic fill. If we continue down to 8 feet, it's going to tell me that it's low. So if it's running out there, you're going to get a low alarm. You can silence it. It's also going to tell the panel. As it starts to catch up, it's going to make its way back up to about 9 feet, and then it's going to shut off the automatic fill. If for some reason it doesn't shut off, it's going to go up and get a high level alarm. So the solenoid valve does have a little restriction to it. If you were in a scenario where you're using a lot of water, you could open up the manual bypass ball valve down there too, and it'll fill a little faster. So.
What if you got a slow leak in your tank and your wells constantly turning on and off? Do you have a meter or something that'll kind of let you know?
No,
Okay.
There isn't. It would just
keep
kicking on and off. Yep. Yeah. If it does, if like say the well died because of that reason or it kicked out on the controller, you would go till you got the low level, and that's a supervisory, just like a low air or a closed valve, that's then going to call people and tell them that there's an issue and they got to investigate. So there is air in the piping, but it's not like a dry system, so we can lose all the air and still not have it activate. So let's go out here for a minute and we'll look at some of the linear heat cable. So here you can pass it around. Here's some linear heat cable. And then here you can see there's 2 different metals involved. And that's how it can measure the change in resistance on both to kind of give us a distance it's at. Here's a piece that we activated. And if you tug on the 2 wires here, you can see that they kind of melted together. So it's designed to activate at about 190 degrees, which should be before a sprinkler head activates. So for example here, if you want to hold that so that you can hear a little better. So right now I have a piece of linear heat cable and you can hear it's not buzzing. I can short it out by kind of cutting it. And then you can hear that it's shorted. So what we'll do, it's slower than a fire, but if we have a heat gun here, we can heat it up. And after 30 seconds to a minute, when it gets warm enough, it'll short out. And that's how linear heat cable works. And a fire is a lot bigger area and puts out a lot more heat, so. So there it shorted out because those two wires melted together. So the only difference between this and the fire alarm system is the fire alarm system's got a resistor on the end, so it knows that it's a complete circuit all the time. So we can go in there and I have a test probe we can put in, and so it'll short out the linear heat, and we'll see that pop up on the fire alarm panel, and then we can read that there's a short there. So the linear heat cable comes into the box up here. And so if I put this in, it acts like a short. So if we take a quick look at it here, the fire alarm panel here, don't ever hesitate to hit buttons, either the acknowledge button or the down arrow, but it's going to tell you the most recent signal here. So LHC for linear heat cable, wire short. Notice it's a supervisory signal, so it hasn't activated as an alarm yet. So if we look here, it tells us that we've got a fault, and it's got a short at 1 foot. That's where we're at there. And then the temperature is 77 degrees. So if everyone wants to kind of get a good peek at those two things. So now we'll go and heat that little probe up there, and then it'll activate as a fire alarm. And then we can look at the display again too. And if someone wants to come over here where they can see it, you'll be able to see it counting up. And ignore the way I'm climbing the ladder too. So you should be able to see it start to go up. So yeah, now if you look at it, we can still see that we've got the short. We can see the current temperature and the maximum temperature. And then if you look on the wall, there is a copy of the map that you were looking at that gives you the approximate distances again. So on the fire alarm panel, notice before we had the supervisory. Now we have a red alarm light blinking, which tells us that it's in general alarm. That's what we get when our first flame detector goes, or this goes. And we have a red release light. That means the system would have discharged water. We have it disabled right now, so it doesn't, but that would be an indicator that you've got a flame detector and it should have released the system. When that happens, once it releases, you would also get a water flow alarm. So if you're on the way here, because you get dispatched and then you get a water flow, that tells you that we went from just having a flame detector to it. The second one went and it released. So I can let the air out of the system and then we'll show you a low air bell. So the panel will tell us we have a low air, which is just a supervisory. But on a pre-action system like this, if we walk over into the drive bay, you'll tell there's a bell that's completely different sound from the horns and strobes. And there's a sign by it there too, but that's to tell you that the pipe's compromised, and then it gets overruled by the horns and strobes. So if you come in and hear that, we've got a low air, but we don't necessarily have water in there yet.